Hi guys. So let's revisit this experimental data about determining the effectiveness of a lie detector. So we have an experiment where 52% of subjects are being told to lie so that we know that they're lying. We have 48% of subjects telling the truth. So when a third party administers a lie detector, a positive lie detector result happens 82% of the time, given that we know that the subject is lying. So a negative lie detector result occurs 69% of the time when we know that the subject is telling the truth. But understand, those are conditional probabilities. Those are probabilities conditioned upon that we know that the subject is either lying or not lying. So what we're really interested in practice when a lie detector test is administered, we don't know if the subject is lying or not. What we see is a test result. So given that we've seen a positive test result, what's the likelihood that the person having the lie detector test applied to them is actually lying? So in order to calculate that probability, we have to consider what we want compared to what's possible. So remember, what we want compared to what's possible. So in this circumstance, we're going to limit ourselves to positive lie detector test results. So again, under the condition, given that we're seeing a positive test result, what's the likelihood that they are also lying? So the denominator that we are interested in, is limiting ourselves to positive test results. The numerator then means what's the likelihood that they are lying? But notice, we're assuming that we're seeing a positive test result already, so we are interested in two things happening. They're lying and we have a positive test result. That's really what we're looking for. So in order to calculate this, we need to organize our data in a tree. So first of all, let's start with whether or not someone is lying or telling the truth. So we'll start our tree that way here. So the likelihood of a lie is 0.52. That makes the likelihood of telling the truth 0.48. So now let's look at the conditional probabilities. Under the condition that someone is lying, the likelihood of a positive test result is 0.82. So under the condition that someone is lying, so that means we're along this branch of the tree, the likelihood of a positive test result is 0.82. So what that means is then the other alternative is the test result could be negative. That's going to happen with a likelihood of 1 minus 0.82, that's 0.18. So same thing could happen. Under the condition that someone is telling the truth, we could see a positive test result or we could see a negative test result. So let's organize that next. So given that someone is telling the truth, the likelihood of a negative test result is the 0.69. So we're on the telling the truth branch. The likelihood of a negative test result, so the likelihood that the actual lie detector person administering the lie detector test believes they're really telling the truth. That's what a negative result would mean. That likelihood is 0.69. So that means the likelihood of a positive test result is 1 minus the 0.69. That's 0.31. So notice, by organizing our probabilities in this tree, these are the initial probabilities. The probability of a lie versus the probability of telling the truth. These are conditional probabilities. Under the condition the subject was lying, this is the likelihood of a positive test. Under the condition the subject is lying, this is the probability of a negative test. Under the condition the subject is telling the truth, this is the likelihood of a positive test. And similarly, under the condition that the subject is telling the truth, this is the likelihood of a negative test. So these are the conditional probabilities. And what we're interested in is the likelihood of a positive test result. That's the first thing we have to think about. In the probability that we're trying to calculate, what's possible is a positive test result. So here we go. There are two ways to get a positive test result. You could be lying and we get a positive test result. You could be telling the truth and we get a positive test result. So notice there are two ways that this could happen. Along this branch of the tree, this is the probability of a lie, and a positive test result. So that probability is the 0.52 times the 0.82. The other way that we could get a positive test result is telling the truth and then getting a positive test result. So along this branch of the tree, this is the truth and a positive test result. So that comes by taking the 0.48 times the 0.31. So we need to go to the graphing calculator. We can calculate those. The 0.52 times the 0.82, 0.52 times the 0.82. That comes up to be 0.4264. I'm going to write that down. Then let's calculate the other one, 0.48 times 0.31. Again, I'll write that down. That comes out to be 0.1488. So here's the situation where we are now. In order to calculate the likelihood of a positive test result, there are two ways that that could happen. The subject is lying, and they get a positive test result. Maybe the subject is telling the truth, and we get a positive test result. This is the only two ways that that can happen. And notice that these can't happen at the same time. These events are disjoint. These events are mutually exclusive of one another. So the probability then of a positive test result, I can just add these together. 0.4264 plus the 0.1488. That will give me the probability of a positive test result. So let's do that. 0.4264 plus the 0.1488. So that gives me the overall likelihood of a positive test result. That's 0.5752. So we're almost done. So now we have the denominator. What's possible? What's possible is a positive test result. So remember what we're trying to calculate. We're trying again to calculate the probability that a subject is lying given that we've seen a positive test result. So what we want is what's possible is a positive test result. That's the denominator. That's the condition under which we're working. That's what's given. Well, overall, the likelihood of a positive test result, we just calculated that using the tree. That's the sum of these possible two outcomes on the tree. That's 0.5752. That's my denominator. But notice, I can see my numerator already in the tree. So this is what's possible. We have to be under a situation where we have a positive test result. That can happen two ways. Lying and a positive test result, truth and a positive test result. Those are the two outcomes that we have to combine to be in our denominator. But the one that we want is the lie and a positive test result. That's what we want. Now notice, this is the truth. Truth and positive test result. This is the one that we want in the numerator, a lie and a positive test result. That's what we want in the numerator, 0.4264. So that comparison, the 0.4264 over the 0.5752, that will end it. 0.4264 is what we want, divided by the 0.5752. So that probability is about, we'll call it 0.741. I'll round it off here. That was the whole goal. So understand what we've accomplished here. This tells us, given that we're observing a positive test result, what's the likelihood that the subject is actually lying? Well, it's about 3/4 of the time. That likelihood is only about 0.741. So the truth is, lie detectors really aren't as accurate as you might believe. So again, this right here is what officers in the field, for instance, face. If they're going to administer a lie detector to someone, we don't know whether they're lying or not. So having gone through the lie detector test, if we see a positive result, how likely are we that they're lying? Well, that probability is only 0.741, and that casts some doubt on whether they're lying or not. It's really not something we can be certain of.